Hi, Mr. Zapone here, and bringing you a video on the Big Bang. It will be a five-part video series just to cut things down to manageable chunks. In the first part here, we're going to talk about an overview of the Big Bang and look at a little bit of general relativity. From there, we'll move on to a video about light, the electromagnetic spectrum, and the Doppler effect. These are just some things we need to know about in order to understand the Big Bang and some cosmology. There's a supplemental video on helium and fission. And then video 4, we're going to provide 3 evidences for the Big Bang. There's actually 4. We'll talk about that. And then video 5, we're going to talk about some nucleosynthesis or nuclear fusion and a little bit of stellar evolution. So hopefully you enjoy this video. These topics are really cool and interesting. So the Big Bang, one of the greatest stories ever told. And basically what I'm going to do in this video series is give you the scientific overview of how our universe and how all the things on planet Earth came to be. There's definitely some religious implications there, and I don't want any of you to feel that this is anti-religious. I myself am a Christian. I believe in God, and I believe when we look at scientific discoveries, when we look at the history of the universe, we're just figuring out how God created things. So this video is not meant to be anti-religious. It's not meant to be pro-religious. I'm a teacher. It's my job to help you think critically, not to, force my religion or my philosophical or political leanings on you. So just realize you can believe this and still be a religious person. You don't have to be, but I just want to make sure you understand that this is not some sort of secular idea. It's just basically the scientific version of how everything came to be. So we are going to learn what the Big Bang is. There's 3 major evidences for it, 4 nowadays, but the 3 traditional ones we'll go over in detail. And those evidences are redshifting galaxies. In order to understand those, we're going to have to talk about waves, the electromagnetic spectrum, and the Doppler effect. A second evidence for the Big Bang is background radiation in space. There's an afterglow from the Big Bang, and we can actually detect it with radio telescopes everywhere we look in the universe. And when we look at young galaxies and stars today, they match up exactly with what the Big Bang model predicts the early universe should have looked like. And by the time we end this, we are going to talk about some nucleosynthesis or nuclear fusion, how actual elements and all the material around us were created. So hopefully you enjoy this presentation. Some of the greatest thinkers throughout the history of time have wondered, where do we come from? How did we get things here? Is matter eternal? Was the earth always here? Where did this metal come from? And we can actually answer that question through science. We know the history of the earth. We know the history of the universe, at least back 13, 14 billion years. So still a lot of unanswered questions, but this is some pretty cool stuff. And yep, we'll talk a little bit about stellar evolution and supernovas. So okay, so let's start with this picture. Here we have a picture of the Eagle Nebula. I think that's M16 for those of you following the Messier catalog. It's a stellar nursery, which that just basically means it's a nebula in space, which is a birthing ground of stars. A whole bunch of dust and gas, and basically gravity pulls this all together, and eventually stars like our sun or much bigger will form. And this is a very famous image, and this is actually very big. This picture you're looking at, the pillars are trillions of miles across, trillions of miles in height. It's just, and this is only a small portion of the actual Eagle Nebula, but this is a great picture from Hubble. So in this picture you see a bunch of stardust, but what does it mean when the Earth and people are called stardust? I'm sure you've said, yeah, we're nothing but stardust. What does that actually mean? Are we stardust? Are we star stuff? Are we dead stars? Where does the Earth and everything on it come from? This is an amazing question that we can actually answer today, which is remarkable. We know the history of the Earth, the 4.6 billion year old Earth. And here's a quote I really enjoy. Hydrogen is a light, odorless gas, which given enough time, turns into people. So we're going to talk about what that means, and we're going to go through that. And hopefully by the end of this 5 video series, you can actually explain that quote to me. Okay, so we have an image up here, just meant a little comic relief. I don't know if you know what a rotary phone is, but that's what we used to use in our homes. Anyways, think about this issue. You have a cell phone. Really could take any object in your house, the human body, the crust, the mantle, our homes, in a tree, in the food we eat, our cars. But we'll just look at cell phones. What elements are in our cell phones? What elements do you think are in there? You want to think about it for a minute or two, pause the video, see if you can come up with a list. If we were in school, we would do this there, but just think about it. I'm going to go forward and show you the answers. So, periodic table of cell phones. And you see there's a lot of elements in a cell phone. A lot. Some you probably didn't expect. You know, there's hydrogen in the, looks like the case. I'm going to throw the mouse on here. Pink, or purple case. There's some lithium. Where do we find lithium? In the battery. Lithium ion batteries. Remember those droids were, like, people were talking about them? They were just, like, exploding in their face or something? That's why we stick with our iDevices, right? But there's a whole bunch of elements in your iPhone. So the question is, where do these elements come from? We know we get them from the Earth. A lot of these metals are mined and ored, and you know we have fancy chemical ways to synthesize a lot of these things from pre-existing materials, mixtures in the environment. But ultimately, were they on Earth forever? Where do they ultimately originally come from? The Earth is finite. It only existed for 4.6 billion years. So this material that makes up our planet, that coalesced under gravity, you know, comes from somewhere else. So where did all the atoms, all the matter in our universe actually come from? Where did all the heavy elements come from? And that's really, really what we want to resolve with this 5-video series. And in doing so, we have to talk about the Big Bang. So we are going to answer this question. We're going to do it in a roundabout way, but we are going to, at the end of this 5-video series, come back and fully answer this with some talk of nucleosynthesis and stellar evolution. All right, so here's another cool image. This is a time-lapse photo. You can look at the dates. You have May 20th, 2002, several months later to September 2nd. And what are you looking at? Does anyone know what you're looking at? It's a pretty cool image. This is actually a time-lapse photo of a supernova explosion. A supernova is a very explosive. It's an explosive star. It's very tremendous amount of energy is released. Sorry, I was looking for the words. It's cataclysmic. It's an extremely violent explosion in space. You might see a star in the nighttime sky just light up for a good period of time. So much energy is released in one of these, but it's basically the death of a massive star. And we're going to talk about that. And how does this relate to our cell phones? We're going to connect this to our cell phones, to the elements in our cell phones. Believe it or not, they are very directly related, where the elements on Earth come from and supernova explosions. So just as we go on, let's just ask, what is the Big Bang Theory itself? Let's just make sure that we define it and we're all on the same page. So the Big Bang Theory, this is from space.com. It's straight from their page. I copy-pasted it. Big Bang Theory is the leading explanation about how the universe began. At its simplest, it says the universe as we know it started with a small singularity, then inflated over the next 13.8 billion years to the cosmos that we know today. That's interesting, to say the least. So my own words, everything in the entire world, everything on Earth, all the planets, moons, stars, galaxies, space, time, matter, energy, and dimensions of our universe were once confined to a super hot, super dense, tiny point that expanded over time into our known universe. So what we're saying is that everything in existence, the entire physical universe, was once in something smaller than the head of a pin. And all of that matter, all of that energy, everything that we can see around us in the whole universe, giant galaxies, our planets, our neighbors, our cars, everything was once confined to this tiny little point that expanded outwards. That's really what the Big Bang is saying. And that's kind of crazy. So naturally, someone told me that, like, yeah, hey, everything was compressed inside of the head of a pin. You know, all the cajillions of tons of matter in the universe, we'd be very skeptical of that. So why do we actually believe this really crazy idea? It's you know, it's like, so in order for scientists to accept this, there's got to be some pretty good evidence, and we are eventually going to go through those. Before we get there, we're going to start with where this idea first sort of arose from, and we're going to start with general relativity. But believe me, I am sympathetic. Big Bang Theory seems a little bit out there when you think about what it's actually saying. But we're going to go through the evidence. So, general relativity, this was Einstein's theory of gravity. We know acceleration of gravity on Earth is about 9.8 meters per second squared. We can calculate on other planets. We also know that if I were to take Einstein, which I have here, and I were to release him, he would fall under gravity. We know Newton's law of universal gravitation. We can do a lot of calculations with gravity. But have you ever stopped to wonder what actually is gravity? We know objects with mass attract one another. We can calculate how much force they attract one another with. But why? Why do objects with mass attract other objects with mass? And that's something we really don't 100% know, but Einstein came up with a theory. He said that gravity itself warps space-time. So I want you to imagine you and three of your friends are each on four corners of a sheet, and you pull that sheet, each of you pulls that sheet as tight as you can, so it's kind of like a flat plane, a really taut pulled sheet with some tension in it. And if you were to put a bowling ball in the center of that sheet, that bowling ball is going to create a divot in there. And it's going to warp the sheet. It's going to basically sink into it. Now, if you were to put any object on there, like a small marble, the marble is naturally going to roll down to the Earth. This is what Einstein said. He said basically objects with mass warp space-time. They actually warp the fabric of space-times themselves. So any other objects that go near them basically fall into them. And that's Einstein's theory of relativity. Now, this theory is what first kind of made the idea of an expanding universe possible, because his field equations allowed for it. So is there any good evidence for relativity? Absolutely. This is one of the most well-attested theories in all of science. So some things that it got right. Newton, Sir Isaac Newton, he could not explain some peculiarities in Mercury's orbit. There's something called the perihelion precession. I'm going to show you a picture of this. General relativity explains it very, very good. And this is observational data, something we see. Ignore that bullet point for now. So here we have Mercury's orbit. Let's look over here on the left version of this. Mercury is orbiting the sun in an elliptical orbit. This is highly exaggerated. It'd probably be more accurate to draw this as a circular orbit. This is so exaggerated, but the planets do have slightly elliptical orbits. But as Mercury orbits the sun, what happens is it doesn't just keep orbiting in the same spot. Follow the mouse. Its orbit shifts. And it keeps shifting and shifting, like kind of one of those like kaleidoscope pen things you might have had when you were a kid. Draw those little spiral art. So Mercury does this over time. Now, Newton's law of universal gravitation did predict it, but it only explains half of its amount. Einstein's theory of relativity, general relativity, I should say, predicts this perfectly. And we have observational data to confirm this. The idea of space curvature and warp time says that light will bend as it passes by massive objects. This is called gravitational lensing, and we can actually see this. This happens in space. GR predicts the existence of gravity waves, which very recently have been discovered. They've been detected, and you can do some research on that. It also posits the existence of those crazy things called black holes, dead stars that are so massive and so dense and so gravitationally attractive that not even light can escape from them. And these things have been indirectly observed. They're believed to be in the centers of almost every large galaxy. And his field equations basically are the basis of modern cosmology. Einstein came up with his theory in 1916. Einstein did not believe in an expanding universe. In fact, he rejected it for a while. But Friedman, and a name that's very, very hard for English speakers to pronounce, Lemaitre, I'm messing it up, but it's as close as I can get, basically extended his field equations to an expanding universe. They showed that general relativity basically says, hey, space-time itself can be expanding. It could also be static or contracting, but they did show this, that, hey, your theory allows a universe where space and time itself not only can be warped by massive objects, but that they could actually be expanding. So this is where the idea of the Big Bang came from. It first started with the idea of general relativity, which basically is extremely well attested in science, and it kind of opened up the idea that, hey, the universe could be expanding, but really no one at the time accepted it because there wasn't a lot of evidence for it. As we move on, we are going to look at some evidence and see the story of how the Big Bang came to be accepted. In our next video, we are not going to look at the three evidences yet. We're going to do an aside, and we're just going to talk about light and the Doppler effect a little bit, because in order to understand these three evidences, we do need a little bit more science refreshing to make sure we know what's going on. So that's the Big Bang and general relativity introduction. Hope you enjoyed this screencast. Stay tuned for the next one, Mr. Sapone.